In this video, we're going to be discussing antiderivatives. So whenever you know the velocity of a particle, but you're wanting to work backwards to figure out what would be the position or the displacement of that particle, you would actually use an antiderivative. Because normally what we have done in the past is we had the position of a particle and we need to find the velocity and the acceleration of it. So we took the derivatives. So anytime you're wanting to work backwards, you have to take the antiderivative. Same thing if you know the rate of water, which is slope, which is derivative, and you want to know the amount leaked over time, again, you would work backwards to find the antiderivative. So the general theorem that states that if f is an antiderivative of f, so basically if this was the derivative, then this was the original function, then the most general antiderivative is f of x plus c, where c is an arbitrary constant. So if you have an antiderivative, that's f of x, and you take the derivative of it, you would get f. But if you take the antiderivative of it, you would get the original function back. So the reason the plus c comes in handy is because let's, for example, say that we have 3x squared and we wanted to know the antiderivative, like what function that when you take the derivative of it, you get 3x squared, which is the same thing as integral. So when you see the word integral, it basically means antiderivative. So again, you're thinking what... Like basically you're saying this is the derivative. What was the original function? So you're trying to figure out like what when I take the derivative of this, I actually get this. Well, x cubed would work because if you take the derivative of x cubed, you would get 3x squared. That's a 3x squared. Well, the only problem is this also gives you a 3x squared as the derivative, because the derivative of 3 it's a constant, so it just goes away, it becomes 0. Same thing with this. If I took the derivative of this, again, I would get 3x squared. Same thing with this. If I took the derivative of this, I would get 3x squared. So the problem with antiderivatives is that there's not just one answer. It could be any answer plus some constant, because constants go away whenever you take the derivative of it. Hence the formula, the plus c. So example, if the derivative was cosine, then what was the original function? So if you think back, what function that when you take the derivative, you get cosine, and the answer is sine of x. And then again, you have to do plus c. Why? Let's take the derivative of this to make sure we actually get this. The derivative of sine is cosine, and the derivative of a constant is 0. So it goes away. So therefore it worked. You have to put a plus c because you're not sure if the original function had a constant. Same thing here. If this is x squared, then what, when you take the derivative of it, will you get x squared? So I know that it's going to be x cubed because when you take the derivative of this, you get x squared. But when you take the derivative of this, you would get a 3x squared. So what you have to do in order to undo that is you are going to divide by that exponent, because when you do that, if I was to take the derivative of this, 3 times a third is just 1, and it becomes x squared. So it did work. Next, if the derivative is 1 over x, what was the original function? So what do you know from all your formula sheets of derivatives that when you take the derivative, you get 1 over x? And the answer is the natural log of x. However, you will notice in your book, you will have the absolute value of x, and that's because the natural log cannot do negative numbers. It can only handle positive numbers when you take the derivative of it. So when you're working backwards, like if x was -3, it would not work. X has to be a positive number, or you just have to make sure to make it positive in order for it to become a natural log. And then don't forget the plus c. And again, up here, this was supposed to be a plus c. So the original functions of what we will do with on a daily basis would be, if it's a power, then what you're going to do, you're going to add 1 to it, and then you're going to divide by that. So for example, if I had x to the 4th, well, the derivative is going to be x to the 5th. Why? Because when you take the derivative, you subtract 1. So to work backwards for an antiderivative, you're going to add 1. And then you're going to divide by that power. That is why whatever the exponent is, you're going to divide by that exponent. If it's 1 over x, the antiderivative is natural log. E to the x, thankfully, is still just e to the x. the exponential, sine, and cosine. So let's actually do one. We know the acceleration of a particle. So if the acceleration is 6t plus 4, then in order to find the velocity, we need to take the antiderivative, because if you take the derivative of velocity, you get the acceleration, so we need to work backwards. So if that's t, then we know the velocity was a t squared. And then this is 6t, but you have to divide by that exponent, whatever 2 is. And what is 6 divided by 2? It is 3. And does this work if you get the derivative? 2 times 3 is 6, 6t. So it did work. And then any constant becomes that constant times the variable, and then again plus c. So if we were to take the derivative of this, do we get 6t plus 4? Yes, we do. Now, they said that the initial velocity is -6. That means that if you plug 0 in for t, you should get -6, because the initial velocity means that time is 0. So I'm going to set the velocity equal to -6. And I'm going to plug in 0 for t. And so c equals -6. So the velocity function is 3t squared plus 4t minus 6. Now we need to go back one more because we want the initial displacement. So now we got to go from the velocity to the initial displacement, which is going to be cubed, because squared means it's going to be cubed. And that's a 3, but we have to divide by the exponent. 3 divided by 3 actually gives you just 1. And then plus 4, it's going to become a t squared, and you got to divide by the exponent. So 4 divided by 2 is 2. And then minus 6, we'll just tack on the variable, and then again plus c. Now take the derivative of this to make sure you actually get this. This becomes 3t squared, that worked. This becomes 4t, that worked. This becomes -6, that worked. But if you plug in 0, you should get 9 according to this. So I'm going to take 9 and I'm going to plug in 0. And I'll get c equals 9. So therefore my displacement function is going to be t cubed plus 2t squared minus 6t plus c. Next example. Now I'm going to move myself up a little bit because we need to know this information down here first. When an object is near the surface of the earth, is subjected to a gravitational force, it produces a downward acceleration denoted by g of gravity. Obviously, the motion close to the ground, we assume g is a constant, which in this case we're going to use the 32 and not the 9 because we're dealing with feet up here. So we're going to use the 32 feet. So we know that the acceleration is 32 feet per second squared. However, it is actually a negative. And here's why. If you think about the fact that you're 432 feet in the air, you you throw off a ball and it's going to go like this. The acceleration is your second derivative. Second derivative tells you concavity, right? Well, we know that this function is concave down. Therefore, the acceleration must be a -32. If the acceleration is this, then we know the velocity is going to be -32t. And it tells me that at the very beginning, at time 0, then the velocity is 48 feet per second. So when we plug, that's supposed to be plus c, sorry. When we plug 0 in, that means we should get 48. So therefore, c equals 48. So we know that the velocity function is -32t plus 48. That is the velocity. Now, the position we know is -32t squared divided by 2. Remember, when you add 1 to the exponent, you got to divide by the exponent. Plus 48t plus c. 32 divided by 2 gives you 16. Now, I also know that a person was 432 feet in the air when he threw the ball. So if I plug in 0 at time 0, we should get 432 feet. So therefore, that means 432 would be equal to when time is 0. So therefore, C equals 432. So we now know that the displacement function is negative 16 t squared plus 48t plus 432. That's the height above the ground t seconds later. Now it's going to say, when does it reach the max height? Max height is when the derivative is equal to 0, right? Well, this is the derivative, the velocity. So if we set the velocity equal to 0, we will get 32t equals 48. So t equals 48 divided by 32, which is 4/3 or 1.3 repeating. So it reaches the max height at 1.3 seconds. Now, it wants to know, when does it hit the ground? So at that point, when does it hit the ground? So what we do is we're going to take the position function and we will actually set it equal to 0. Now, there's two different ways you can solve this. You can either use the quadratic formula, or you can take the graphing calculator. Now, if you pull up the calculator and you type it into the calculator and find the 0, you'll be able to figure out where it hits the ground. So if you hit graph, okay, so it's going to hit the ground at that point. I don't know when I toggle over, so I'm going to change the window a little bit. I don't need any negative y values really, because we only want to know when it's positive, when it's above ground. But I'm going to make the y max a little bit bigger to 100. Okay, so this is where it's going to hit the ground in this spot. So I'm going to hit second trace. I want to know the 0. So I got to toggle. Toggle. Okay, my y value, okay, there it is. I'm going to hit enter for the left bound, hit enter for the right bound, hit enter, and that gives me 6.9. So therefore, I know that at 6.9 seconds, it is going to hit the ground. So here are a couple of examples that you can attempt to try to figure out the antiderivatives of. So pause the video, try these 3 problems, and then resume whenever you want to see the answers. Okay, so for the first one, if this is the derivative, then the antiderivative is going to be x to the 4th, but you got to divide by 4. So that is going to be a 1/2. This is going to be 2/3 x to the 3rd, but then I got to divide by 3. So therefore, that is going to become 2/9. And then 4x, that becomes a squared, which means you got to divide by 2. So that is going to give you a 2. And again, if you take the derivative of this, you can be able to check it. Oh, don't forget the plus c. I always forget that. So 4 times 1/2 is 2, and then x to the 3rd, that worked. 3 times 2/9 because gives you 2/3, which works, x squared. And then 2 times 2 is 4x, so it worked. This next one, 3x to the 1/2. Now, remember, in this case, you're adding 1. So 1/2 plus 1 gives me 3/2. And then I'm going to divide by 3/2. Oh, hang on. 3 divided by 3/2 is 3 times 2/3. Okay, so it's a 2. Again, if you remember how to divide with fractions, you KFC, keep the first, flip the second fraction, and then multiply. And then next, you get minus 2x to the 1/3. You add 1, so 1/3 plus 1 will give you 4/3. But you got to divide by 4/3. 2 divided by 4/3 is the same thing as 2 times 3/4, which is 3/2. So that becomes 3/2. And then plus c. Last, the 1/5 just gets to have an x. And then remember, this is 2 times 1 over x. Now, we talked about a minute ago that 1 over x, the antiderivative of, is the natural log. So this is just 2 natural log of x and plus c.